Welcome. Previously, we looked at calculating areas of region bounded by graphs. At that time, we looked at situations where the graphs didn't cross each other within the region of interest. In the region, one graph always was complete above the other. What if that's not the case? So let's look at a specific situation. Here I have the graphs of y equals x cubed minus 5x squared plus 6x and y equals 2x. The two graphs, if you graph them, you see intersect at 3 points. So part of the time, 2x is above the other graph. In other portions of the interval, it's below the other one. So in this case, if we just use our formula top minus bottom, we run into a problem. There are two ways to handle this. One, which looks nice but is not very useful for evaluation using the fundamental theorem, is to actually write down what the height is. If I take any vertical strip, in this portion, the height is 2x minus x cubed minus 5x squared plus 6x. In this portion, it's x cubed minus 5x squared plus 6x minus 2x. So we have to change the order of subtraction. I can say just take the absolute value. The distance between 2 points along the y-axis or along a straight line parallel to the y-axis is the absolute value of the difference between the y-coordinate. It's not very useful for calculating definite integrals by the fundamental theorem because there is no formula for integrating absolute value. For numerical integration that might work, but not for fundamental theorem approach. In this case, we will just divide the region into portions, where in each portion we have one graph completely above the other, and so that the difference between the two functions has the same sign. So in this case, if the original functions are nice enough functions, we can do the antiderivative. We don't have to worry about absolute value messing up the antiderivative. Let's start by finding the points of intersection of the two graphs. So we just set the two equations equal to each other and solve for x. This time we get a cubic equation, but it factors. I can first pull out an x. Quadratic factor is x squared minus 5x plus 4, which factors as x minus 1 times x minus 4. So I get 3 points of intersection, which matches the picture we have. We have x equals 0, which is this corner, x equals 1, and x equals 4. So I divide the region into two. Portion marked 1, the curve is above the straight line. X goes from 0 to 1. In the part marked 2, x goes from 1 to 4, the straight line 2x is above the curve. We'll set up the integrals for the areas of the two regions separately. So for the first one, x starts at 0, goes up to 1. Remember that the curve x cubed minus 5x squared plus 6x was above the straight line 2x. So we subtract in that order and then calculate the integral. If I do the subtraction, I get x cubed minus 5x squared plus 4x. And antiderivative is x power 4 over 4 minus 5x cubed over 3 plus 4x squared over 2, which is 2x squared. I take the net change from 1 to 0. So substitute 1, substitute 0, and subtract. Because if x is 0, the antiderivative is 0. And if you simplify this, you get 7 over 12. For the second portion, where x runs from 1 to 4, the straight line 2x is above the curve x cubed minus 5x squared plus 6x. So we subtract in that order. Distribute the negative, becomes 2x minus x cubed plus 5x squared minus 6x. And if I combine the like terms, 2x minus 6x is negative 4x, so I get minus x cubed plus 5x squared minus 4x. Note that this is the negative of the integrand in the previous portion. This is why you can try to combine them by saying take the absolute value. Because if you take the absolute value, these two will be the same. Of course, we have to get rid of the absolute value to do the antiderivative. And what we are doing is figuring out in which intervals this is positive, in which intervals it's negative. In that case, you change the sign, which is equivalent to what we did. So the rest of it is straightforward. Do the antiderivative. Of course, this will be the opposite of this, and then take the net change from 1 to 4. So substitute 4 for x and substitute 1 for x, and then subtract. If you do all the arithmetic, it should come out to be 135 over 12. The total area is area of the two portions added together, which is 142 over 12, or if you reduce it, 71 over 6.